Okay, let us discuss. In this problem we have to calculate resonance energy of naphthalene. So we have to find a resonance energy. So this is the resonance energy. So we have to find resonance energy for naphthalene. The question gives some value. Now let us first calculate heat of formation of naphthalene. So first thing that is given, combustion of naphthalene is given to you, C10H8. So let us write heat of combustion equation. So this plus O2, and this will give you CO2 plus H2O. That is a general combustion equation. H2O is a liquid and this CO2 is a gas, and this is of course gas, and this is the solid. Naphthalene is solid. Now for this reaction delta H is given, that is heat released, heat evolved. So this means minus 5157. This is minus 5157 kilojoule. Now I can calculate delta HF for C10H8 naphthalene by using CO2. Heat of formation energy for CO2 is minus 393.5. So this is minus 393.5, and heat of formation for H2O is minus 286.0 kilojoule. And now this is a stable form, so this is 0. So I have to calculate heat of formation for C10H8. Now if I use delta H is equals to heat of formation of product minus reactant. Now before that I have to balance this equation also, so I have to multiply by 8. No, carbon is 10, so I have to multiply this side by 10, and this oxygen, hydrogen 8, so I have to multiply this by 4, and similarly I have to multiply oxygen 10 into 20 plus 4, 24, so I have to multiply by 12. Are you getting or not? So for oxygen I have to multiply by 12. So this plus I have to multiply this by 12. Now let us find heat of formation into 10 into this product minus reactant. So 10 into minus 393.5, and for H2O, so 4 into minus 286.0, and this minus, so this is the product, so this is the heat energy of product minus reactant. Reactant I have simply 0 plus delta HF of naphthalene. So from here I can get the naphthalene energy. So this is minus 5157. This is equals to 39 minus 3935, and minus this will be 286 into 4. So let us write 286 into 4 and minus delta HF. So I will have delta HF. This is equals to minus 3935 minus 286.4 into 4, and if this goes this side, this becomes plus 5157, plus 5157. Now calculate this value. So we will have, this value is minus 3935 and minus 286 into 4, and then you have plus 5157. This is in kilojoule. So this comes out 78 kilojoule. So plus sign. So with a plus sign, heat of formation of naphthalene is plus 78 kilojoule per mole. Are you getting? And now I will use the bond energy data. We can write the heat of formation of C10H8 using another form also. So C carbon solid plus 4 mole of hydrogen. If I take, I will have C8, 5 mole of hydrogen I have to take. So let us say if I take 5 mole of hydrogen, and then I will have C8, 8 mole of carbon I have to take, C8H10. So this will give you heat of formation, that is the value we have calculated, 78 kilojoule per mole. Now you see, we can calculate this value using the Born-Haber cycle also. So first I have to atomize this carbon solid to carbon gas, and there are 8 mole of carbon, and then I have to atomize hydrogen, getting or not? So I will have, so let me see, I think I have done something mistake. This is C10H8, C10H8, so I have to write C10H8. So this is, I have 10 carbon and 8 hydrogen. So let us rub this one. I think all of you have done right. So this is C10H8. So I have to multiply this by 4 and this by 10. So this means I have to give some energy, so that I will have 10 mole of hydrogen atom, 8 mole of hydrogen atom. So I will have 8 mole of hydrogen atom. And in this case, energy is given atomization energy, or you can say sublimation energy of carbon. So this is given. So sublimation energy of carbon is, you see here, 715.5, 715.5. So 715%. I have to give this energy 715 and this 0.5. So for 10 mole I have to multiply this by 10 also. So because I have 10 mole, so I have to multiply this by 10. Now I have to rub it here and let us write 10. So this is 10 mole of carbon. So this is the amount of energy given. Now similarly for hydrogen, atomization energy, what is the bond energy of hydrogen? It is 436. So I have to give this much amount of energy, 436 into 4. So this much amount of energy I have to give. Now I have carbon and hydrogen, and we can make the bond between carbon and hydrogen, so that I can have naphthalene. So naphthalene molecule is this. So from here I can make the naphthalene. So let us write. So this is the naphthalene molecule. Now if this process, hydrogen carbon hydrogen makes this naphthalene, some amount of the energy will be released. How much energy? So how many carbon carbon double bond I have? I have 1, 2, 3, 4, 5 carbon carbon double bond. So amount released is 5 carbon carbon double bond. Now how many carbon carbon bond? 1, 2, 3, 4, 5, 6. So I have 6 carbon carbon single bond. And how many carbon hydrogen bonds? So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 carbon hydrogen bonds. So these all energy will be released, because bond formation energy releasing process, carbon carbon double bond, this energy is 617. So this is 5 multiplied by 617 and plus 6 carbon carbon single bond. So this is 345.5. so 345.5. so this energy is 345.5. Now let us say this energy, carbon hydrogen bond energy. So carbon hydrogen bond energy, this bond energy is 413 kilojoule per mole. So this value is 413. Now I have this naphthalene. So this much amount of energy is released, because this is the bond formation process. So this is the energy released. So let us put a minus sign. Now this is a benzene, but now this is in gaseous. Naphthalene is in a gaseous form, not in solid form. Let us say now two processes I have. First is resonance stabilized. So these double bonds are basically this time localized. So this double bond are localized double bond. Localized. Now if resonance takes place, so this becomes something like this. Now this is the resonance stabilized naphthalene. So some amount of energy has been again released. Let's just say minus Re, that is the resonance energy that has been released, but still this is in a gaseous form. I have to have, that is a here, that is the basically solid form. So some amount of energy is still released, because naphthalene is just solid and this is gas. So some amount of energy will be released, and that is given to you. Heat of sublimation of energy of naphthalene, 72 kilojoule. So this means if you sublimate, if you go from solid to gas, you have to give 72 kilojoule energy, but if you go gas to solid, this energy will be released. So this is minus. Now apply the Hess law. Energy from this side or energy from this side, both has to be same. That is the one important point we have here. So let us calculate. So this is 78. So I can write a equation. So this is 78 is equals to This is the 78 from this side. It has to be equal from this side. So this is 715.5 multiplied by 10. So this is 7155. Are you getting? So let me check again. Carbon sublimation energy is 715.5. Okay. Now this one 4 into 436 plus 4 into 436. So this energy, and then you have to subtract this energy. 5 into 617 plus 6 into 345.5. So this is only calculation, plus 8 into 413. So this is the amount of energy released, and then you have a resonance energy that is released, and then you have heat of sublimation energy that is released. So now calculate this value separately. So 78 is equals to, I can use the calculator. So this is 7155 plus 4 into 436. So this value is 8899. So this value is 8899. Now calculate the second value. So this value, let us do this one. So I have 5 into 617 plus 6 into 345.5 plus 8 into 413. So this value is, let us calculate, 8462. So this value is with a minus sign. 8462 minus resonance energy minus 72. So now I can calculate the resonance energy. So what is the resonance energy value? So if I take resonance energy this side, so I will have 8899 minus 8462 minus 72 minus 78. So let us calculate this value. So I will have 8899 minus 8462 minus 72 minus 78, and this value, let us check. This is 287. Now this is a positive value. So this energy is 287 kilojoule per mole. Are you getting or not? So this is the amount of energy that has been released. Because I have assumed the resonance energy is negative, you say here I have taken resonance energy is negative. This means 287 kilojoule energy has been released. So you see, if you have somewhere here, if this naphthalene is your localized naphthalene, this is your localized naphthalene has energy this, and now your delocalized naphthalene is having 287 kilocalorie or kilojoule energy, less energy. So this is delocalized, resonance stabilized, but this is not resonance stabilized. So this is the resonance energy for this question.